The journey began long before any of us were born. A small craft, no larger than a household appliance, was sent on a path no human eye had seen. Voyager 2 slipped away from Earth in 1977, leaving behind the blue glow of our planet and the warmth of our star. What followed was not simply a voyage through the solar system. It became a slow, steady fall into the deep unknown. One by one, the giant planets drifted past its cameras. Jupiter with its swirling storms, Saturn wrapped in its impossible rings, the icy giants Uranus and Neptune spinning in the cold shadows. Voyager did not rush. It observed. It listened. It learned. And as it traveled farther, the familiar glow of sunlight stretched thinner and thinner until it became nothing more than a dim echo behind it. After passing through the frigid outskirts of the Kuiper belt, it entered a region where our maps ended. A place where the solar wind grows weak, where the sun's touch begins to fade. For decades, astronomers imagined this boundary to be gentle, like fog dissolving into open air. But Voyager found something far different. Engineers on Earth continued to track its faint heartbeat, a whisper of radio waves traveling for billions of kilometers. Those signals should have faded long ago. Its power supply should have weakened beyond use. Yet the spacecraft endured, pushing farther than any machine in history. And then came the moment that changed everything. As it approached the edge of the heliosphere, the protective bubble shaped by our sun, its instruments began to sense strange shifts. Charged particles moved differently. Magnetic fields twisted in ways no model had predicted. What was supposed to be a gradual transition became a sudden, jarring boundary. It was as if Voyager had collided with an invisible wall. Inside that wall, the sun holds sway. Its winds, its radiation, its magnetic field, all combine to create a shield that surrounds our entire solar system. But beyond it lies the interstellar gulf, a place ruled not by our star, but by the raw forces of the galaxy itself. Voyager's sensors recorded a jump in cosmic radiation, sharp, immediate, unmistakable. Plasma density spiked. The magnetic field shifted abruptly. The change was so sudden it was almost violent. For the first time, we had evidence that the edge of the solar system is not soft. It is sharp. It is defined. And it is alive. The spacecraft had crossed into a new realm. A realm no human-built object had ever entered with its instruments still functioning. A place where ancient starlight drifts unfiltered, where cosmic storms travel across unimaginable distances, and where the sun's protection no longer reaches. Voyager had stepped beyond the boundary of home. And the galaxy welcomed it with turbulence. What scientists once imagined as a quiet, empty stretch between stars revealed itself to be filled with motion, waves of radiation, shifting magnetic currents, and unpredictable bursts of energy. Nothing was still. Nothing was calm. Interstellar space, it turned out, was not empty. It was dynamic, restless, and filled with forces we had only guessed at. Back on Earth, the signals arriving from Voyager carried a message more profound than any greeting encoded on its golden record. They said that the universe beyond our solar system is not a silent void. It is a place of storms and structure, a vast ocean with currents we are only beginning to understand. The deeper Voyager moved into interstellar space, the stranger the environment became. For over 40 years, its engineering team had grown used to its steady rhythm, its slow pulses of data, its familiar patterns. But in 2019, everything changed. For the first time in decades, Voyager 2's transmissions fell silent. No data. No telemetry. No hint of life. The spacecraft that had survived radiation belts, micrometeoroids, temperature extremes, and the edge of the solar system's shield suddenly vanished into quiet. Engineers feared the worst. A failure at that distance would be final. No repair, no reset, no second chance. Hours stretched into nearly a day. Then, unexpectedly, a signal flickered through the darkness. Voyager had restarted itself, as if jolted awake by something in the void. The official explanations pointed to aging hardware. But the data captured before the blackout told another story: sharp bursts of energetic particles, sudden distortions in the magnetic field, unexplained spikes in plasma density. It was as if the spacecraft had crossed through a pocket of electrically charged chaos, a turbulent knot in the fabric of interstellar space. Scientists realized then that the region beyond the heliopause is far more irregular than anyone imagined. Radiation levels rose and fell unexpectedly. Magnetic fields twisted in patterns that seemed almost deliberate. Waves of charged particles swept through with the behavior of storms rolling across an unseen sea. And then came a discovery that no one expected: alignment. The Sun's magnetic field, stretching outward for billions of kilometers, was found to line up nearly perfectly with the galactic magnetic field outside the heliosphere. They met not in conflict, but in harmony. The chances of such symmetry occurring by accident are extraordinarily small. It suggested two startling possibilities. Either the heliosphere is powerful enough to carve the surrounding galactic magnetic field into shape over millions of years, or our solar system formed in a region that was already aligned, as if placed there intentionally, like a piece fitting perfectly into a cosmic design. The questions this raised were immense. Did our star reshape its environment, or did it drift into a region already prepared for it? Are the forces of the galaxy shaped by randomness, or by patterns we have not yet learned to recognize? As Voyager moved farther from home, its presence carried another weight. Attached to its side is the golden record, engraved with sounds of Earth, greetings in human languages, and a map pointing unmistakably to our star. It was meant as a gesture of peace, a message of curiosity. But now, knowing how reactive the boundary of our solar system is, some scientists wondered what that message truly represents. If something in the galaxy were to detect Voyager, the record would reveal exactly where we are. It is a beacon, one humanity launched long before we understood the turbulence beyond our protective shield. Voyager continues on, drifting deeper into the galactic sea. Its voice grows fainter each year, yet it still sends home bits of information no other mission can replicate. It has already reshaped our understanding of the edge of the solar system, revealing it as a sharp, dynamic threshold rather than a fading transition. It showed us that the galaxy is active, unpredictable, and filled with invisible storms. Nearly half a century after leaving Earth, Voyager 2 has become more than an explorer. It is a silent messenger carrying our presence into a realm that existed only in theory before it arrived. What awaits out there remains unknown. But its journey reminds us that the universe is far more alive, structured, and mysterious than we ever imagined. And as it drifts into the darkness between stars, a quiet question follows it through the void. Is Voyager simply wandering?